Hi, I'm Les Smith, Automation Specialist dealing with standard drives with the McNaughton-McKay Electric Company. In this video, we'll be talking about PowerFlex 525 drives and parameters to help troubleshoot them. Key parameters to help troubleshooting a PowerFlex 525 drive. First one would be parameter 12, control source. This shows us the owners of the start command and the speed reference. Parameter 13 will show us inputs 1 through 3 and the dynamic brake chopper. And parameter 14 will show us inputs 5 through 8 and their configuration. Digital input 1 does not have a parameter, but we will talk about that later. Parameters 62 through 68 are the configuration for the digital terminal blocks 2 through 8. I'm going to use Connected Components Workbench. I have a video drive ready for this project. We'll click onto it and bring up the parameters. And we will go to the custom group where we have a pre-configured drive already waiting for us. Here we look at control source. And we go to the question mark, and it will show us bit descriptions. You expand that, and you can see digits 1, 2, and 3. 4 and 5 are out of sight. However, I would like to go to the user's manual, which serves this purpose better. And we go down to the Help tab, and go to the Product Manuals. Use the manual. And then we'll do a search for control source. We'll load that into the Shift Control search key. Control source, hit enter. We get a list, and we'll expand to fill the screen. And then we'll scroll down to get a full picture of parameter 12. Here we see bit 0 equaling 1 through 5 and the descriptions. Then we look at the frequency command source, and which is bit 2 and 3, and the descriptions for those bits. Here are some display reads for that word. 2004 means that the network option will start it, and the frequency speed will be the purge speed. This is out of the HVAC industry. Next, we'll look at 113, whereas the start source is a DSI port, possibly a auxiliary HIM, and then 11 is a PID output. Next would be 155, which would be a start source from the internal Ethernet port, and speed reference is 15, which is from the internal Ethernet port. Next would be 52, and your start source would be a digital terminal block, possibly a run, forward, run, reverse, or a start, and then a 0 to 10 analog input for the speed reference. And the last one, 011, is start source is the keypad, and the speed source is the drive pot. This is the default value when the drive is initially purchased. On our demo here, we see that it is 44, and that means that we have a network card that is controlling start, stop, and also speed reference. Now, the control status word, we'll double click on the name, and this will tell us that bit 1, terminal block 1 is on, a start button is there and is not pushed, and or the jumper is in between 1 and 11. The other two blocks that we have, terminal block 2 and terminal block 3, have no input to the drive at this time. And then the third bit, bit 3, is the DB transistor on. This will show us whenever the dynamic braking is turned on. If I go up to the question mark and scroll down, there is a definition there that the bit will be on for a half a second minimum whenever the chopper is on. You can see that with the display pad on the drive if you look at that word. Next one will be the digital input status, and that's the remainder of the digital inputs, terminal block 5, 6, 7, and 8. These can be defined as needed. What I like to do if they're not used is I like to turn the definition off or the description off. Simply go and put a 0 in at all inputs to disable them. The reason for doing that is if you have a stray wire that would land on those blocks, they will override the existing configuration and likely give you added time in troubleshooting. If you don't program them, they will not activate then. Another group of parameters to help troubleshoot a PowerFlex 525 drive are the regulators. Parameter 36 is the RPM of the motor. This is on the slip regulator, and then we'll talk about parameter 550, the bus regulator, enable it and disable it. And then 484 is the current regulator, and we'll show some adjustments on that. And then last would be the overload counter, which is parameter 369. We'll first take a look at parameter 36. In this example, we're setting at 1750 RPM, which is motor nameplate. Synchronous for a 4-pole motor is 1800. If we wanted to turn off the slip regulator, we would program that 1750 to synchronous or 1800. This will turn off the slip regulator and cause it not to inject the 50 RPM when full load amps is accomplished. You can turn it back on and see if that helped or hindered your process afterwards. Next parameter would be parameter 550, which is the bus regulator. We'll scroll down and find it at the bottom. And it is, this time it's enabled. If you want to turn it off, just simply disable it. Disabling the bus regulator would keep the drive from extending either the accel or the decel time in case we have bus overvoltage approach. You can use this to see if your drive performs better without tripping out, and then turn it back on after your short experiment. Now we're going to parameter 484, which is the current regulator. You notice here it's set to 3.8 amps by default, but we can increase it up to 4.5. You would possibly see frequency fall off under severe loads if we reach the 3.8 amps. If you increase it to 4.5 for a short duration, your process may speed up to full RPM, and this will tell you that you have possibly a sizing program with your drive and or your motor, and that should be studied at the time. When you're done, set it back to 3.8. Next parameter would be 369, which is the motor overload level. This is for the motor overload counter, which will count up to 100% when we have exceeded the motor overload level, and then we will trip out on motor overload fault. If you monitor this, this will tell you the health of your drive and motor, how heavily it's being worked. Normally you'll see it setting at 0 all the time. If you see it to start increment up, you know that you're starting to exceed your load. We'll look at the fault queues that we have in the drive. There will be 4 of them, and their parameters will have 10 parameters per buffer, and the latest fault would be fault Q1, the next would be 2, and so on. These will store the faults at the time of the fault. They'll store the parameters. So we'll take a look at fault frequency first, which would be 631. If you hit the question mark here, this is going to store parameter 1 in parameter 631 for the first fault queue. The next one would be parameter 641, and that is the current fault. Bit 3 or word 3 would be stored in parameter 641. Then the third buffer would be for the bus voltage, which is going to be parameter 651, and that will store bus voltage, parameter 5, into the buffer starting at 651. Then the last buffer would start at 661, which is the status, and this will tell you, have the status words, the bits being bit 0 through 4, and whether it's running, a 1 will be there if it was running at the time of the fault, and then the next one, a 1 will be there if it's forward. If not, it's going reverse. And then the other two would be if it's accelerating or decelerating. And then the last bit would be for a safety active at the time of the fault. And that would be bit 6 being stored into the queue starting at 661. For additional questions or more videos like this, please call or visit our website.